So the last part of 3.4 is talking about correlation versus causation. So you want to be able to figure out the correlation of a particular situation and figure out if there's a cause and effect relationship. So correlation, remember, is when two variables have a relationship with each other. So if it's a positive relationship or a positive correlation, both are increasing at the same time. If it's a negative correlation, then as one thing decreases, the other is increasing. Causation. Causation is a cause and effect relationship. If two variables have a strong correlation, it's tempting to conclude that one variable causes the other, but just because two things are correlated, that does not mean that there's causation. So just because there's a relationship, a positive or negative correlation between two things, it doesn't mean that there's a cause and effect relationship happening there. So here we have the Family Circus cartoon, and little Billy says, "I wish they didn't turn that seatbelt sign on so much. Every time they do, it gets bumpy." So Billy noticed that there's a correlation between the bumpiness of the plane and the seatbelt sign, but he thinks that it's a cause and effect relationship. Billy thinks that the seatbelt sign causes the turbulence. Obviously, just flicking the seatbelt sign on isn't going to cause the plane ride to get any bumpier. So let's look at another example. The correlation coefficient between sodium content and the number of calories for fast food items is R. Remember, that's our correlation coefficient variable. R equals 0.81. So if you think back to when we were talking about our correlation coefficient, 0.81 represents a fairly strong correlation, right? A fairly strong positive correlation. And that's kind of displayed in our graph over here, that positive correlation. So this means that items, food items with higher sodium content tend to have a higher number of calories. So our question is the higher sodium causing the higher number of calories? Well, if you think about sodium, sodium does not have any calories. Therefore, sodium can't cause the higher number of calories in the food. So there's that relationship, right? As the sodium goes up, food tends to have a higher calorie content, but since sodium has no calories, it is not causation. So it's correlation, but not causation. Let's look at another example. So what type of correlation would you predict between shoe size and reading ability for 5 to 18-year-olds? Well, if we're looking at our scatter plot, notice as shoe size is increasing, our reading score is increasing. So since they're both increasing, we have this positive correlation going on. So we have to ask ourselves, are these two variables just correlated, or do we think that the shoe size causes children to read better? Well, no, right? It's not causation. Just because your feet grow, that doesn't automatically improve your reading ability. There's a relationship because as your feet grow, you're getting older, so you're going to school, you're practicing reading, you're becoming a better reader. So there's a relationship there, but just because your feet grow, that is not going to change your reading ability at all. Let's look at a couple more. So for each situation, we want to answer, is the correlation positive, negative, or is there none? And then we want to say, is this causation statement true or false? So is there cause and effect, or is there not cause and effect? So number one, the shorter amount of time it takes to get to class versus the number of tardies you get at school. So looking at if this is positive or negative, well, the shorter amount of time tells us that our time to get to class is decreasing, and the number of tardies we get is increasing. So decreasing and increasing, that tells us we've got a negative correlation going on. Our causation statement says, therefore, when you have less time to get to class, you get more tardies. Well, I mean, if you think about what if they reduced the class time to 1 minute? You only had 1 minute to get all the way from gym over to the 1600 wing for Algebra 1. You'd probably get more tardies, right? So that less time for you to get from class to class, that would cause more tardies. So we could call this true. Number two, the more hot chocolate consumed versus the increased number of people who go sledding. So more hot chocolate, so the amount of hot chocolate is increasing, and increased number of people going sledding, so people going sledding is increasing. Well, if they're both increasing, we've got a positive relationship going on. And then a causation statement. Therefore, drinking more hot chocolate makes people go sledding. So is this true or false? Well, if I gave you a cup of hot chocolate right now, would it make you go sledding? Probably not, right? Especially because there's no snow right now for you to sled. So this is a false statement because um, hot chocolate cannot cause a person to go sled. So, correlation versus causation, remember you're asking yourself, is there a cause and effect relationship for causation, or are the variables merely correlated? Remember to answer the questions at the bottom and hit submit when you're done.